We said already that, so I will go right into the topic. It feels like I have presented this thing too much in the last months, but I will start from the top. So the inspiration for this project was that maps are key tools in Earth system science for information communication, and that map reading involves complex spatial reasoning. And with latest advancements in computer vision, such as visual question answering, we now have new ways to access map content. And what is visual question answering? It is this computer vision task that enables the machines to comprehend the content of an image, and it allows the user to interact with the image by means of natural language in question and answering mode. And it can help with visually impaired individuals to access content in figures for the very first time, to overcome language barriers. For example, if a map is in Chinese and you don't know Chinese, you can still interact with it in the language that you know, for example, English. And to assess the content similarity maybe for multiple image inputs, etc., etc. So that's why VISQAM was conceived, to enable visual question answering. And the idea is basically that we have a model that receives an image and text as inputs. So the text is a question that refers to the image, and then the model processes these both inputs and prints out the hopefully right answer. And here we have an example from the data set. It's the image is sourced from the European Center for Middle Range Weather Forecast. It is about the precipitation type over the Pacific region, and the question is there rain or snow in Mexico? Mexico is here. You can't see the legend because it's too small, but there is rain over Mexico, and that should be the answer of the model, and that is the answer. So yeah, for this we built an open data set of annotated thematic maps, and we fine-tuned a small Quen 3VL model to offer a baseline for the visual question answering task. Our data sources are mainly four different. One is the Copernicus Urban Atlas, that is land use, land cover maps at European geographic scope and at the metropolitan region level. The other is the Copernicus Atmosphere Monitoring Service and the European Center for Middle Range Weather Forecasts, that visualizes climate variables such as temperature, methane, precipitation type, as we saw before. It covers global scope, and it focuses on a continent or greater region level, such as the Pacific, that we saw in the previous image. Our world in data that contains choropleth maps. We chose only variables that focus on environmental factors. It covers again a global scope, and the maps cover continent level. And then we have some miscellaneous maps from scientific journals, but mainly from the UBMAP-L dataset. And we chose them to add some more diversity in the map layouts because all the previous three categories are quite uniform. So yeah, there are a variety of topics, but with an environmental focus. The geographic scope also varies quite a lot, and also the scale varies quite a lot. To come to the annotations part, so we chose to follow an established taxonomy for question answering from a GQA dataset that is about visual question answering again, but for general images. And this taxonomy categorizes questions in 2 dimensions: the structural, that is how the question will be answered, basically, and the semantic. We defined 34 template questions, and we randomly assigned 3 to 5 question answering pairs to each image. And now the dataset verification is still ongoing. We already have verified and delivered 800 images out of the target 2,000 that we have, and this includes over 3,000 verified question answering pairs. I accidentally clicked. Hopefully you can still see my presentation.
Yes.
Good.
Still okay.
So this is how it looks, the data set. It's delivered in COCO format, and we have here an example image from the Copernicus Atmosphere Monitoring Service about fire activity over northeastern Europe. And you can see here, I will not go through the whole thing, but here you can see width, height, file name, license, date capture in Unix format, source URL. Source URL is kind of our own adaptation of the Flickr URL, that is the COCO format. And then we have added also the QA annotations under every image that contains a list of the question answering pairs. And here the question is, what type of map is this? This is a thematic map showing fire activity. And then we have also added annotations for every legend in the dataset. Very few maps contain 2 legends, but most of them contain only 1. We have not done anything yet with the legends, but it's still there. It's delivered with the rest of the dataset. And now for the baseline model, its main purpose is to show the usability of the dataset and to provide a reference for thematic map question answering tasks. We fine-tuned a small version of the Qwen3VL model, and we chose this one because the flagship, the big equivalent, was the highest ranked open weights model in the Vision leaderboard in the arena.ai as of December 25. And now I think it's Kimi, another open source, an open weights model, took over already, but we have done the work already in Qwen3VL. And yeah, we chose a smaller model for basically resource reasons. Now for the deliverable. And the data set on Hugging Face. You can find the fine-tuned model on Hugging Face, and you can find the Jupyter notebooks showing the fine-tuning, the usage, and the evaluation that we used on the GitLab of NFDI4Earth. And to show you very quickly how to use, unfortunately, I cannot show you. I would like to show you live, but that requires me to connect into the high-performance cluster of the university, and it requires me to also have a VPN connection, and we don't have the time for that, I think. So if you want to use it, you have to go to the GitLab of NFDI4Earth. You have to navigate to the cookbooks, which contains the Jupyter notebooks, and you choose the fine-tuned model, Jupyter notebook. You follow the instructions there, and I have taken a screenshot of what is basically what you could change according to what you want to test. Here in the test image, you can change the URL. And here is the question, basically. What type of map is this? What is this map about? I'm sorry. I chose another example to show you. So you can see here the land use land cover map of Genève. And the question is, where is the highest concentration of urban fabric? And our model printed in the central area of the city, which is correct. Again, it's quite small, you can see it, but everything that is pink is the urban fabric, and the darker, let's say, the hue, the denser it is. And just for your reference, I also queried the base model before we fine-tuned it, and it gives a very, very generic, a very long as well, and a very generic answer about where are the highest concentration of urban fabric encountered, like universally. You can see here New York, London, Tokyo, etc. I have to admit, it gets better if you explicitly ground the question to the input image. But still, it's not concise at all, and it can yield a lot of problems. So yeah, I would say for starters, the fine-tuned model is definitely more concise, it's more to the point, and it's therefore more economic because less tokens are used. And to give you an idea about our results, so of course the exact match before fine-tuning and the validation split was 0, but that was to be expected. It's raised to 0.27. And we also use the BERT score F1 that compares the answers in the semantic space. And from 0.43, it raised to 0.72. And this is only with a portion of the data set delivered. We still have over thousands that we would like to verify. And yeah, switching to the roadmap, we want to integrate more batches in the verified data set. And we also want to enable legend understanding using the bounding boxes because, I mean, they're already there, so we might as well use them. And before I close this presentation, I'm very proud because this is an in-house effort, the TIFGI, and the contributors beyond me are Ajay, Ahmad Abubakar, and Yom Naid. And yeah, this was it. I made it very quick, but if you have any questions, I'm happy to answer them.